Welcome back to the Deep Dive. Today we're looking at something beyond just, steady progress. It feels more like acceleration. Like the future isn't just coming, it's here, full speed ahead.
That's right. We've been looking into a range of sources, all pointing towards China's massive mega projects, things in infrastructure, energy, AI projects so big they honestly sound like science fiction.
And there's this really provocative idea floating around in these analyses, isn't there? This claim that the pace is so fast, some Western experts are saying countries like the US, the UK, France, they're, at least 100 years behind?
Yeah, that's the line you see. And it's less about pure technical know-how, maybe, and more about, things like political will, how fast regulations move, and where the big money is being directed centrally.
Right, the ability to just do it.
Exactly. So our mission today is to explore 4 key areas where China seems to be really pushing the boundaries of what we thought possible, and maybe understand why that 100 years claim is even being made. Let's start under the sea.
Okay, sounds good. So beneath the waves. This must be the Bohai Undersea Tunnel project, connecting Dalian and Yantai up north.
That's the one. And the scale is, it's vast. The plan is for about 123 kilometers in total length.
123 kilometers. How does that compare to, say, the Channel Tunnel?
It's roughly double the length, so significantly bigger. But it's not just a road tunnel. It's planned as a 3-part system.
Yeah.
Cars, yes, but also a dedicated railway line. And crucially, it's designed for bullet trains running under the ocean.
Bullet trains under the sea. Okay, now that journey across the Bohai Strait, it used to take ages, right? Like 8 or 9 hours?
Exactly. A long ferry ride. This tunnel, especially the high-speed rail part, would cut that down to just 40 minutes.
40 minutes. From 9 hours, that's transformative.
It really is. You basically create a brand new economic corridor overnight. It's not just about saving time. It's projected to unlock potentially trillions of yuan in trade annually. It's a huge signal of what the sources call China's technological autonomy.
Meaning the ability to reshape their own economic landscape almost at will.
Precisely. But building something that long, that deep, especially with high-speed rail, the engineering challenges must be immense. What about things like earthquakes?
Yeah, that's a major point in the sources. The tech isn't just about digging deep. They talk about this floating segment design.
Floating segments, what does that mean?
Well, it's not literally floating, of course, but it uses AI-controlled systems and sophisticated water pressure balancing. Think of it like giant shock absorbers built into the tunnel structure itself, deep underground.
Ah, so it can handle seismic stress better.
Apparently, yes. The engineering goal is that even during a major, magnitude 8 earthquake, the tunnel itself would only experience a slight tremor.
That implies incredible confidence in the design.
Okay, so they're tackling distance underwater.
Yeah.
What about speed on land? That brings us to maglev, I assume.
Exactly. If the tunnel conquers distance, maglev conquers speed. It's all about magnetic levitation. The train literally floats above the track.
Right, suspended in a magnetic field. No wheels, no friction, which means incredible speeds. The sources mention up to 600 kilometers per hour.
600. Just to put that in perspective for listeners, imagine a trip like, say, Karachi to Lahore. That could potentially be done in about an hour and a half.
That's fast. But beyond the speed itself, what's the strategic angle here in terms of this leadership theme?
Well, the key point the sources emphasize is how it was developed. This train, currently the fastest land vehicle, was reportedly developed entirely in-house by Chinese engineers.
At the CRRC factory in Qingdao, right? Over about 5 years.
That's the one. And crucially, without relying on Western tech or companies, it's presented as proof that, quote, technological leadership is now in Asia's hands. They own the whole process, start to finish.
Which means they could potentially deploy it anywhere, export the whole system. Okay, so speed and infrastructure tackled. But real global influence needs energy independence. Is that where the artificial sun comes in?
Precisely. That's the next big leap. We're moving from reshaping the Earth to trying to replicate a star. The East Reactor project in Hefei. The goal is nuclear fusion, like the sun, but here on Earth.
Fusion power. The dream of clean, almost limitless energy. But the temperatures involved are astronomical, aren't they?
They really are. The sources state it achieved 150 million degrees Celsius.
150 million? That's, 5 times hotter than the sun's core?
Roughly, yes. And obviously, any physical container like steel would just vaporize instantly at that temperature.
So how on earth do they contain it? What's the trick?
Magnets. Extremely powerful magnetic fields. They create a sort of invisible bottle suspending the superheated plasma away from the reactor walls.
A magnetic bottle. Wow. And the payoff if this actually works at scale.
It's potentially world-changing. If they perfect it, it could theoretically provide limitless clean energy. No more reliance on oil, gas, coal, no pollution.
That's the ultimate game changer. What kind of timeline are they talking about? Is this decades away or?
They have a very ambitious target. The stated goal is to get most of China's national energy from fusion systems like this by 2050.
2050, that's really not that far off in the grand scheme of things.
No, it isn't. The sources frame it, if successful, as potentially one of the biggest achievements in human history. Total energy security.
Okay, from limitless energy, the next logical step is how you use that energy in production, right?
Yeah.
Manufacturing. China's already the world's factory, but this sounds like a shift.
A major shift. Moving from human labor, even skilled labor, towards fully autonomous, AI-driven manufacturing. Think robots operating 24/7.
But these aren't just robots doing repetitive tasks, are they? The AI component sounds more advanced.
Absolutely. We're talking about systems that don't just run machines. They reportedly make their own decisions, they can correct mistakes as they happen, and even communicate with other robotic systems to optimize the whole workflow.
So replacing human hands with AI minds, essentially.
Yeah.
Cementing their role as the factory of the future.
That seems to be the goal. Highly efficient, fully autonomous production.
Right, so if energy and production are increasingly automated and efficient, what about the places people actually live? Cities are getting crowded, land is finite. What are the future solutions there?
This brings us to some really futuristic concepts for urban living. When you can't spread out anymore, you go up or you go onto the water. Let's start with the idea of the vertical city.
A vertical city. Is that just a really, really tall skyscraper?
It's more integrated than that. Think of a single, massive structure, yes, but designed to contain everything a community needs. Homes, offices, shops, parks, entertainment, a self-contained ecosystem, basically.
So minimal travel needed within the city. Much more efficient.
Exactly. Reduces energy for transport, services, everything. A completely different model from urban sprawl.
And if building up isn't enough, you mentioned going onto the water. Floating cities.
That's the next frontier, according to these sources, for when land is truly scarce. These concepts are for self-sustaining cities built on modular platforms at sea.
Self-sustaining how?
Designed to generate their own power, likely solar or wave, and grow their own food, maybe hydroponically, and importantly, engineered to be resilient against natural disasters like typhoons or sea level rise.
Integrated resilience again, it's a pattern.
Yeah.
And within existing cities, dealing with traffic jams today, flying cars, are those actually becoming real?
They seem to be moving faster than many expected, yes. Presented not just as a cool gadget, but as a practical necessity to solve urban gridlock by opening up airspace for short-range travel.
So adding a third dimension to city transport.
Pretty much. The sources suggest we could see these becoming visible, maybe even common, in cities globally sooner than we think.
It's quite something to step back and look at the whole picture. You've got mastery under the sea with that massive tunnel.
And on land with the 600-kilometer maglev.
Harnessing the power of the sun with 150 million degree fusion.
And then reimagining cities entirely vertically or floating, run by AI factories.
And connecting it all with flying cars. It really covers earth, sky, and energy, doesn't it?
That seems to be the strategic aim described in the sources, yes. Achieving that technological autonomy across all key domains. And you can see why that 100 years behind comment gets made. It's the sheer breadth and speed of execution.
It is stunning. But pulling off so many giant projects simultaneously, that must require an unbelievable amount of capital, right?
Yeah.
Did the sources talk about the financial side, the risks, the sustainability of spending at this scale?
That's a really important question, and yes, it does come up. The advantage of a centralized system is that it can direct massive resources towards these national goals, maybe in ways Western private finance models couldn't easily replicate.
But the risk?
The potential risk highlighted is about efficiency and centralization. Is all that capital being used in the absolute best way? What happens if a cornerstone project like Fusion hits a major unexpected delay after so much investment? So there's a potential cost to this velocity, but the strategic choice seems clear. They believe the speed is worth the risk.
So wrapping this up, what does this potential future mean for everyone listening? If clean, limitless energy becomes reality by 2050 and AI handles most manufacturing, what happens to existing industries? What happens to jobs?
It implies a really profound shift, doesn't it? If energy is no longer scarce and robots do much of the physical production, what does human work even look like? The sources suggest technological innovation itself might shift away from building things or finding resources.
Towards what then?
That's the big question, isn't it? Maybe towards managing these complex automated systems, or perhaps towards entirely new areas of creativity, science, social organization that we can't even fully imagine yet. What becomes the next great human endeavor when basic needs like energy and production are potentially solved by technology?
It certainly makes you think about what skills will be valuable, what areas are worth exploring now to be ready for that kind of world. A future that might be arriving a lot faster than we expected.
Indeed. Definitely something to keep an eye on and maybe ponder what comes next.
Thanks for diving deep with us today.